The Strathcona Refinery, located in Edmonton, Alberta, was built in 1947 following the discovery of petroleum in Leduc. Although the original refinery was built to refine 7,000 barrels a day of raw crude, a growing demand led to a complete rebuild of the refinery in the 1970s. The Strathcona Refinery has now been in operation for more than 65 years, producing almost 200,000 barrels a day, or 30% of Western Canada's refining capacity. It produces a wide range of petroleum products, including gasoline, aviation fuels, diesel, butane, propane, heavy fuel oils, and asphalts. Utilizing ExxonMobil's best practices and quality assurance, the Strathcona Refinery has improved crude processes and management along with their reliability. This has allowed for record capacity utilization and energy performance, increasing production by 5% over a one-year period. Now, let's take a look at an animated clip that shows the basic overview of the refining process.
So how do we turn raw crude into the useful products that people need? The refining process includes 4 basic stages: distillation, conversion, treating, and blending. Distillation separates the molecules into various components by heating the crude oil up to 350 degrees Celsius as it enters the distillation tower and turning it into a vapor. As the vapor rises inside the tower, it cools and condenses into its various molecular components, which are captured and processed into different products such as butane, propane, diesel fuels, and jet fuels. The types of products that are made from the vapor is determined by the raw crude input, time of year, and market demand. Conversion processes some of the heavier components of the crude in the fluid catalytic cracker, or CAT. Here, the large, heavy molecules are exposed to a catalyst that cracks them into smaller, lighter molecules that can then be turned into high-quality gasolines. Treating removes natural impurities in crude oil such as sulfur and nitrogen, which is essential to meet stringent product quality specifications and environmental standards set out by regulators and government. The treated pure products can then go through the blending stage to produce fuels that suit different types of vehicle engines and weather conditions.
Now, after watching that video, you should have a general understanding of the refinery process and how it works. Here is a simplified plot plan diagram of the Strathcona Refinery. As you can see from the legend, we have split the refinery into 4 primary processes as shown in the video, and also by tanks and miscellaneous areas. Just as a quick note, we can see that the 4 primary processes are concentrated on the west side of the refinery, and a lot of the remainder of the refinery relates to storage tanks as well as miscellaneous areas. So we'll start off with the first process, distillation and heating. From our plot plan, we saw that there are 2 major areas that are responsible for this process. Take a look at these areas that are boxed in green from a view here in Google Earth. This will give you a better view of where these units are located in the refinery. Now let's take a dive into some 360 photos of these units. Feel free to scroll and move the screen to take a better look around the area.
So now taking a look into the refinery on a ground level view, you can see one of the main distillation towers of Strathcona. This tower is located in the southwest quadrant of the refinery and is one of the towers identified in the plot plan. Now before the crude even enters the distillation tower, it is heated to between 340 and 370 degrees Celsius to begin the evaporation process. From there, the crude is then separated into its components, which is collected by steel trays on different levels within the tower. This process is repeated multiple times until the desired purity of the products is achieved. Now looking at some 360 photos of these units in the refinery, we can see some of the main units used for the conversion process. Again, to recap, the conversion step of the refinery process is to separate hydrocarbon molecules to make lighter products. To complete this conversion step, a process called catalytic cracking is used. Carried out at 500 degrees Celsius, this process of catalytic cracking converts 75% of the heavy products into gasoline and diesel. To further convert the heavy products into lighter products, a process of hydrocracking may be used. However, the complexity of this process usually adds more cost. Looking at some of the 360 photos for the treating units we have identified, here are some of the main units. The main purpose of the treating process is to remove or significantly reduce molecules that are corrosive or that can cause air pollution, like sulfur. In this process, diesel undergoes desulfurization at 370 degrees Celsius, and automotive fuels are treated to increase their octane ratings. For this reforming process, which occurs at 500 degrees Celsius, platinum is used as the main catalyst. This is the final step before the products are blended together. These 360 photos are of the blending units in the refinery. Blending is the process in the refinery where the products that have undergone the previous 3 steps are mixed in with the other products and chemicals such as butane and other additives. In blending the products with these additives, the fuel quality is enhanced and can have various benefits that add value to the end customer.